Welcome to Ask and Learn.
This is the answer to Chapter 21, problem number 50 from the Smith Organic Chemistry textbook. And so this problem gives us a starting material and then a reaction sequence, a series of reactions, and asks us to identify every intermediate in this series. And we're given a little bit more information. We're told to only consider para products when an ortho-para mixture could result from an EAS reaction. And then we're also given some NMR spectra information about the final product in this sequence. And so this type of problem shows up a lot on exams and is actually quite applicable to actual experimental organic chemistry because this is sort of how you plan a sequence to make a molecule that you need or a molecule that you want to make. But the difficulty with this, of course, is that if you get the very first one wrong, every answer after that will also be wrong. And so it's important to make sure that each of these is a correct answer. And so we'll take them one at a time. So from the starting material to molecule A, we are told to use bromine and FeBr3. And so that is going to, those conditions are going to be the conditions that we need to brominate our aromatic ring here. So that's going to simply add a bromine. So there's our intermediate A. So from intermediate A to intermediate B, it looks like we're doing a Friedel-Crafts reaction. And the way that you know that is because we're using an acid chloride and we're using aluminum trichloride. And so those are indicators that this is a Friedel-Crafts type reaction. So CH3COCl, COCl, and iron 3 chloride. Okay, and so that's going to add this acetyl group here. And we were told in the instructions, once again, to only consider para-type additions when a mixture of ortho and para is possible. So we will only consider the para product here. So there's our para product, and that's B, as I said. So then going from B to C, it looks like we're asked to use ethylene glycol and some acid. And so, of course, we should know from this chapter that's going to be indicative of acetal formation. So this third reaction is an acetal protection of the ketone that we just added. So there's our aromatic ring. There's our bromine unaffected. And then here is going to be the acetal that this makes. So there's the acetal, and this is intermediate C. So then to get from intermediate C to intermediate D, we're told to use just magnesium metal. And so we should look at this and think about earlier chapters and stuff. And so we have a bromine, and we're using magnesium metal. And we should recognize that this is going to be making a Grignard reagent. So we're making a Grignard reagent we're setting the stage for a Grignard reaction, which will be the next reaction in this sequence. So there's our acetal that we made. And then here we now have MgBr. And this is intermediate D. And I'm actually going to put it above it this time because we're going down next to keep this all on one page, hopefully. And so we have our Grignard reagent, and we're going to treat that with this aldehyde, acetaldehyde, and some water. And so acetaldehyde, water. And so this is going to be a Grignard reaction that we're doing here. So here's our aromatic ring. Here's our aldehyde. And so now we can see why not aldehyde, acetal. And now we can see why we had to protect this ketone by making the acetal, because otherwise we would get equivalents of this molecule adding to one another instead of adding to this acetaldehyde, which is the desired reaction here. And so this is going to now look like this with the alcohol there and a methyl group. So that's going to be E. So that's intermediate E. So the next step in this sequence is just PCC. So of course PCC is an oxidant. So we're going to be oxidizing that alcohol that we just formed up to a ketone. So there's our ketone. There's our acetal still intact. This is intermediate F, of course. And then to get to our final product, intermediate G, we're going to do a little treatment with some acid water, and that's going to hydrolyze our acetal and get us back to the ketone there. So it looks like we're making a nice symmetrical molecule here. So ketone there, installed by the Grignard and then oxidation, and ketone here, installed by the Friedel-Crafts protection and then deprotection. So two ketones. And then we should consider the piece of spectral information that we're given, which says the proton NMR spectrum of G shows two singlets at 2.6 and 8.18 parts per million. So we're told that we should take that into account and think, well, does this make sense? And then again, that's a terrible G. This is G, our final product. So we're told, what was it? 2.6 and 818, right? Okay. So 2.6 ppm and 818 ppm. So can we rationalize these in terms of this final product that we've gotten to by following the sequence? And indeed we can. So each of these signals is a singlet, we're told. And so our 2.6 signal is going to be the three protons on each of these methyl groups. So it should, whatever its relative integration is, its actual value, it should be accounting for 6 protons, because it's going to be each of those groups of 3, but of course they have no neighbors, so they're not going to split, so they're going to show up as singlets. And then likewise, the 8.18, there are protons at each of these unsubstituted positions on this aromatic ring. They are all in identical environments, and so they are going to show up also as a singlet and integrating to an actual value of 4. So it's going to be one singlet that accounts for all 4 of these protons. And 8.18 is indeed a reasonable shift for aromatic protons in this system. And so the spectral information that we have does make sense with the product that we determined from following the reaction sequence. And so that's probably the best way to handle that information here, is just to use it as a confirmatory piece of evidence. And otherwise, the way to approach this problem is just you have to know what each of these sets of reagents does and just be able to follow it a step at a time. And so that's the answer to chapter 21, problem number 50.